Okay, good morning. Sorry I'm not here today, but we are going to move on with notes. Don't worry about this subject 10.4. We are talking about hyperbolas, and you should already know a little bit about ellipses. You should already know a little bit about circles as well. And today's hyperbolas. And hyperbolas are kind of like two parabolas going in different directions. They can open what we call left and right. Okay, we'll figure out how to graph these two, or they can open up and down like this. Obviously, left and right will be an x axis or an x direction horizontal major axis. They call it a transverse axis, or in this case, the y axis or vertical would be your major axis. And everything is very similar to ellipses. So hopefully you remember the ellipse equation. The ellipse equation from before was x squared over a squared plus y squared over b squared equals to 1. And this was for an ellipse. And if you look over here, I hope you can see this, but a hyperbola is the same basic format, only instead of adding, you are subtracting the equations. And this is very important because now subtraction order matters. Meaning, if you did 3 minus 2, you get a very different answer than 2 minus 3. So once again, to figure out which way these hyperbolas will open, the easiest way to identify it is what is written first. So in this case, the x is written first because x will take precedence. You're subtracting the y from the x, so this will always open left and right, like that. However, if y is written first and you're subtracting x from y, then it'll open up and down more along the lines like this. Okay? But notice it's the exact same equation. So our center will always be at what's called h comma k. In this case, our h comma k is 0, 0, so we don't see it there. And we have foci at the exact same equation, only because this sign is different than the ellipse equation, our foci equation has a plus. So it's exactly the same thing as Pythagorean theorem. All right, remember those foci. This time when you graph these, the foci will be somewhere in between these hyperbolas or parabolas. If you think of them like two parabolas, they aren't really. I don't know where those are. I'm just kind of guesstimating where they are right now. But they'll be somewhere in between, and all these ordered pairs, x's and y's, and all these ordered pairs, x's and y's, will all be equal distant from the sum of those foci. All right. We also end up getting what's called asymptotes. I hope you remember asymptotes from Algebra 2. And they're hidden lines, obviously. I'm going to show you how to get those. But they are kind of like a diagonal line that will make this branch and this branch down here asymptotic, and the same thing over here. We can see that this branch at the top and this lower branch at the bottom will be asymptotic. And then obviously we can go this diagonal as well, and we can see this branch and this branch over here are asymptotic, and the same thing this way, asymptotic. I'll show you how to do that. So if you remember how to do an ellipse, then you actually already know how to graph a hyperbola. It's just slightly different, okay? And we'll talk about how to get these asymptotes as well. So I'm going to go through a couple equations real quick, and then I'm going to ask you to do some equations as well. Make sure you understand what's going on. Hopefully you can with your table. And then the assignment has been posted on Google Classroom. And I want to make sure that you look over the review. You will have a CBA... I think it'll be next week, at the end of the week, or right after the 3-day break after we come back from Martin Luther King Day, I believe it is. So double check on the calendar, and I have added a slight difference to the way you can receive your bonus points. Okay, so make sure you read that. You must post 2 questions and answer 3 questions on the review. All right, so read that, and we'll talk more about it if we need to on Monday, if you come see me on Monday, or else on Tuesday. Okay. All right, so we're going to identify the vertices, foci, orientation, etc. from all of this problem right here. Very simple to do. All right, first thing you should always do is identify your center. That's what I do, at least. It's not going to be written up here. My center here will be 0, 0. So I'm going to graph 0, 0. All right, and since x is written first in my hyperbola, it's hyperbola because you're subtracting, and since x is written first, the orientation will be a horizontal orientation. It will open left and right. Okay, And that means whatever is under x, this is automatically going to be my a number, no matter what. This is always my a number. Like before on ellipses, whatever was the bigger of the two would be your a number, and this one, however, is not the case because order matters when you subtract. Okay, so a will be exactly 3 right here, which means our b number will be 16, b squared will be 16, so b will be 4. And what I'm going to do is I'm going to do the same thing, pretend it's an ellipse. I'm going to graph 3 to the right and left horizontally. I'm going to graph 4 up and down from the center vertically. So from here, 1, 2, 3, put a dot. Over here, 1, 2, 3, put a dot. And then vertically, 1, 2, 3, 4, put a dot. Vertically, 1, 2, 3, 4, down, put a dot. And if this was an ellipse, we would connect those circles, all right, those dots, to make that ellipse. Instead, what I'm going to do is I'm going to draw a box around these. And this is, to me, the easiest way to understand how to graph a hyperbola. You'll see other people say different things, and they'll ignore all this. But that right there lives everything that I need to know about a hyperbola, and for that matter as well, it lives the ellipse. If that was a plus sign, we would now have our ellipse, and we're finished. So it's a very similar equation. Okay. All right. So what we're going to do then, at this point, we are now going to draw a diagonal line from corner to corner through the center, and this is going to be our asymptote. Okay, so make sure it's not exactly, when I draw it, say a diagonal line is going to be a dotted diagonal line. So that is one asymptote. And over here we're going to get the other asymptote. Notice it's going corner to corner again through the center. All right, and now I'm basically done with my graph. I just have to remember that it's going to open in the x direction because x is written first. So I graph kind of a parabola, but it's not a parabola because there's two of them. And I just hug my graph as best I can, and that is my graph. I am finished graphing it. Okay, I just need to now finish these little pieces as well. All right, and my vertices, I only have 2 vertices. They are basically the what would you call that? I guess the vertex of the parabolas. There's 2 of them. Obviously, if 0, 0 is my center, I went 3 to the right and 3 to the left from that. So I'm going to kind of take a shortcut and say I'm plus and minus 3, comma 0 for my vertices. I've just written it twice, even though I only wrote it once. Okay. My foci are now in the equation, c squared equals a squared plus b squared. That's supposed to be a c. All right. A squared is in my equation already 9. B squared is in my equation 16. So c squared is 9 plus 16, which means c squared is 25, which means c is plus and minus square root of 25, or 5, from the center in the major axis direction. All right. So from here, if I'm at this center, I go 1, 2, 3 for my focus, 4, 5. I'm sorry, this is my vertex. 4, 5 to my focus. So that's where my focus is going to be. The focus will always be inside your hyperbolas. Okay, so that ordered pair is at 5, comma 0. And on the left, 1, 2, 3, 4, 5, negative 5, comma 0 would be the other focus. So I'm going to kind of cheat again. I'm just going to do plus and minus 5, comma 0, because only the x number moved. Okay, and the last thing we have to do is take into account these asymptotes. All right, the asymptotes obviously are these lines. We want to know those equations because they are going to make these branches of the hyperbolas, hug on either side. So let's see, if this is our center, these asymptotes are lines, so they're going to always be written in the y equals mx plus b format, or you could write it in point slope format, which we'll do if we have a different center other than 0, 0. But this is pretty straightforward because this is my center, and I want to get to that little corner because it has to go through that corner. I do a rise and run. Rise, 1, 2, 3, 4. Run, 1, 2, 3. And it's kind of nice because if you notice, b is 4 and a is 3. So my equation here is rise b over run a as your slope. Rise over run. And then, of course, your y-intercept is 0, so you don't have to put plus 0 there. You're already done. My other asymptote is going to be the same rise, but the opposite run. So basically, I'm going to say I could have plus and minus 4/3 x, and that's going to account for 2 different equations. And now I have all the information that I need. I have my graph. I know where my asymptotes are, where my foci are. I know where my vertices are. I know it opens left and right, or I'll just put a horizontal orientation. Okay. So, if you want to try this one with your table, you can pause the video here and see if you can come up with these answers as well. I'm going to move on. Hopefully now you have done that. I'm not going to answer any other ones on this graph because these are the same exact idea. Center is 0, 0. This time your A value is 4. Your B value is 1. Over here, your A value is 5, your B value is 5. And the only difference is now they will open up and down because Y is written first. So if I go through this really fast, I'll show you 0, 0 is your center. We have an A value of 4. So I'm going to graph 1, 2, 3, 4 with a dot and dot. My B value is 1 because you got to put this over 1. So 1 squared is still 1, so B is 1, so it's going to be a dot here and a dot here. And this is my really thin box right here. My asymptotes, let's see, they're going to be kind of steep because this is a hyperbola, something to that effect. And since it opens in the Y direction, I have my hyperbola going this way. Try to make it a smooth curve as best you can. So that would be my graph, and I would just write down my vertices. Orientation this time is vertical. The asymptotes would be, let's see, B over A, 1 over 4. Y equals plus and minus 1 over 4x, so I go up 1, 2, 3, 4 over 1. Let's see, we did something wrong. Oh, no. The rise and run, I just wrote it wrong. 4 over 1, so 4x. Okay. And then, let's see, anything, plus and minus 4x, up 4 over 1. Foci would be at c squared equals a squared plus b squared. So c is going to be plus and minus root 17 from the center in the y direction. So that's a little more than 4. 1, 2, 3, 4, a little more would be right inside there. Alright, so again, if I was going to write the foci, it would be plus and minus, it'd be 0, comma, plus and minus root 17. Alright, and the vertices obviously are 0, plus and minus 4. Alright, so that's a real quick vertical hyperbola. Okay. What I want to make sure that we can do, however, is if I give you the information, you can now write the equations. Okay, so we're going to have a center of 0, 0, and they're telling us the vertices and the foci. So from here, let's see, we know this is a hyperbola, so we know we're subtracting x squared and y squared, so the order matters. So let's see, what we're going to do is we're going to see our vertices. The vertices are always the major axis. So if I'm going plus and minus 3 in the x direction, that tells me x is the major axis, so I can put x squared first and y squared second, and I know all hyperbolas equal 1. And then I'm going to use this and say, well, if that's my a number, then I square a for my equation. It doesn't say what your b is, so I'm going to use this focus along with this vertex, and I'm going to write my equation. That would be my c squared value, this is my a squared value. I'm going to find b squared. So I know, according to the equation for a focus, c squared equals a squared plus b squared. So I'm going to write 16, because that's c squared, equals 9 plus b squared. So if I subtract them, I get 7 is equal to b squared. And I can stop right there because b squared I need in my equation. So I'm going to write a 7 there. And that becomes my equation. Alright, so why don't you try perhaps this one, of vertices of 0, 5 and 0, negative 5, foci of 0, 8 and 0, negative 8. So pause the video real quick, see if you can come up with that. Alright, hopefully you have that. So let's see, I'm going to write, in this case, my y values must be written first. I'm going 5 units up and down, so that makes it 25. My focus is 8 units up and down, so let's see, my equation would be 64 equals a squared plus b squared. So if I subtract 25 from 64, it looks like 39, I believe. So that would be a 39 right there. And that becomes my equation. Alright, going backwards, what if I give you the graph, you write the equation? So same exact idea. What I would do here is understand that it's opening left and right, and my center is 0, 0, so this has to be an x squared minus a y squared equal to 1. I'm going to find the a value, and what I'm going to basically do is connect these focus points, my foci, and my corners of the asymptote. So that's like my little box right there. And what that's going to do is it's going to tell me what the A and the B numbers are. So let's see. From my center, I go over 1 to the right, 1 to the left. So that tells me 1 is my A value. And if I square 1, I still get 1. So it's got to be x squared over 1. Or you could just leave this as x squared. Since I'm going up 1 right here, that means I'm going up 1 right there, which means this is also a 1. And there's my equation. Okay? Maybe you can pause the video here and try number 10. Do it the same way. I will write it here in a second, but go ahead and pause it yourself. Alright, hopefully you have an equation and you can match it. Let's see, again, this is going left and right, so I know it has an x squared and a y squared that I'm subtracting. And 0, 0 is my center, so I didn't have to worry about anything other than write that format. Let's see, I'm going right 2, so I'm making that a 4. I'm going up 3, so it's got to be a 9. So that becomes my equation, x squared over 4 minus y squared over 9 equals 1. Okay, very straightforward, very similar to ellipses, but very different at the same time. So the only thing I want to do now is talk about what if you don't have a center of 0, 0. Well, then we just order in h and k. Okay, so same exact idea. H goes with the x value, k goes with the y value, and if they switch, notice nothing changes except the a's and the b's are still the same spot because whichever one is first order matters, and that's going to take precedence. Okay, the foci are still the same exact equation, and the vertices are 2 points away from the center in that major axis direction. Okay, there is a little equation that you can use for the asymptotes if your center is not 0, 0. That shouldn't say 0, 0. That should say h, comma k. And this is using point slope form. I don't know if you remember that from Algebra 1, but point slope form says y minus y1 equals the slope x minus x1, and you can always just count your slope once you graph your equation, but y minus k will always be on the left side, x minus h will always be on the right side, and it's nice and easy to remember because you're looking at your y minus k and you're looking at your x minus 8 in the actual equation. Alright, so let's go ahead and do number 11 here and then see if you can't do 12 the same exact way. So this time the only difference is we have a new center. Alright, my center is 2, comma, negative 3. So I'm going to graph 2, negative 3 right there. That's my center. Alright, I got that from 2, negative 3. It's going to open in the x direction because x is written first and I'm subtracting. So I'm going to go 3 right and left, 4 up and down from the center. 1, 2, 3. 1, 2, 3. Those now are actually my vertices. So if I wanted to, I could write my equation. If I know my center is 2, negative 3, I'm going to add and subtract 3. So let's see. 2 added 3 makes 5. 2 subtracted 3 makes negative 1. And then I can just double check. 1, 2, 3, 4, 5, negative 3, negative 1, negative 3. They both match up. Alright, I need to do my B axis. 1, 2, 3, 4. 1, 2, 3, 4. And what I like to do personally is I like to draw in this box. And now I can draw my hyperbolas. Or sorry, my asymptotes. Okay, from here I know it opens in the x direction, so I'm going to kind of graph my hyperbola as best I can, nice and neat. Please do the best you can with these asymptotes. It should be hugging those. So there is my graph to that effect. Let's see. My orientation is horizontal. My foci are always c squared equals a squared plus b squared units from the center. So I don't know what c squared is, but a and b are staring at me. So c squared is 9 and 16, which makes 25. So c is plus and minus 5 from the center. So this time I'm going 5 right, 5 left from that, which means if I add 5 in the x direction, I get 7. And if I subtract 5, I get negative 3. 1, 2, there's a focus. 1, 2, there's a focus. So I have 2 focuses, foci. And the last thing is the asymptotes. And since my center is not 0, 0, I can kind of follow this equation. Alright? So I'm going to keep the y and the k next to each other. So I'm going to write my equation as y plus 3. So I'm going to keep that part of the equation because it's y minus y1, and y1 was negative 3. It's going to equal my slope, and if you don't remember it's b over a or a over b, you can always just go from the center and count your slope. It's a slope of 1, 2, 3, 4 over 1, 2, 3. So it's 4 over 3, and it's going to be plus and minus because you have a up and over to the right, up and over to the left. And then it's going to be x minus 2 because we have shifted our center. And now what you can do is you can either leave it this way. I don't even have a problem with you writing it like that. Some of you guys might want to find each individual one, which would just be distribute and then bring the minus 3 over. But I think this is perfectly fine for writing your two asymptote lines, because that is the equation for those asymptote lines. Alright, see if you can practice this one with your table. Same center, slightly different axes that you're going to have, which would obviously make a different asymptote as well. I'm going to move on the back. Let's see, I want to go backwards here. If you have a different center, they don't even tell you what the center is, but we can also find these equations. Let's see, my vertices are 3, 1, and 3, 5. So notice on this one my x stayed the same, but my y's changed. So I'm going to use this graph and kind of give you a visual of what's happening. If those are my vertices, I'm going to count 1, 2, 3, 1. And 1, 2, 3, 1, 2, 3, 4, 5 right there. Those are the vertices. If they're the vertices, then my hyperbola is opening up and down. So that means my center must be right in the middle at 1, 2, 3, 1, 2, 3. So that tells me my center is 3, 3. Now I can start writing my equation. I know it's going up and down, so the y value must come first. So it's y minus k squared over something. Subtract x minus h squared over something equals 1. Alright, now it's telling me my focus is at 3, 0. So 1, 2, 3, 0, there's a focus. And 3, 6, there's a focus. So in essence, my parabolas are going to, or hyperbolas are going to open up and down somehow. I don't know exactly where, so I'm just kind of sketching so you can see what's going on. But I can use now my focus equation, which is c squared equals a squared plus b squared. And my a value is from the center to the vertex. And so it looks like that's a distance of 2. So that's going to be 2 squared is going to be 4 in my equation. And then the focus distance from the center is your c number, so 1, 2, 3. And then if you square it, you get 9. So now I have a new equation. I can find b. B will go down here. And by the way, since that was 2, I can put a 4 there already. I'm done. So this becomes subtract 4. 9 minus 4 is b squared. So 5 is b squared, and I just put a 5 there. I don't have to solve for what b is. I can just solve for b squared and put it in my equation. Okay. You can try this one with your table. Vertices of 2, negative 1, and negative 4, negative 1, with a focus of 3, negative 1, and also negative 5, negative 1. So pause the video there so you can do that. Last thing I want to do is talk about a hyperbola. If I give you the equation, you're going to have to complete the square. And we did this a little bit the other day. So what we'll do is we'll first always group our values. And remember again, if this is a hyperbola, then you are subtracting. So when I look at this, this is a negative x squared value, but this is a positive y squared value. So this is going to be the leading term. I'm going to put those together. So I'm going to write y squared minus 2y. I'm going to group the y's together, and I'm putting that first again because it's the positive one. I'm going to subtract the x terms. And then I'm going to kick out any numbers so I can balance my equation on the other side. I'm going to move this negative 19 over to make 19. So that's kind of what I'm focusing at. I'm going to go ahead and complete the square here, and if you remember, you always take the b term, take half of the b. So that would be a minus 1. And I kind of like to combine terms, skip steps, because I already know the process. And we're going to take half of that, so it's going to be negative 1, and you're going to square that. That would be a perfect square. If you FOILed this out, you would get y squared. You'd get negative 2y. And then when you multiplied this last term here, you'd actually get a plus 1. So what we've done is we've actually arbitrarily added 1 here, though we don't see it. So I'm going to add 1 on this side to balance it. So now I've just completed the square with the y's real fast. Took half of that, and then I mentally FOILed that out, checked it, and then balanced it over here. I'm going to do the exact same thing with the x's, only we can't complete the square unless we have an x squared term that does not have a coefficient. This one has a coefficient of -4. So what we're going to do is we are going to factor that -4 out. And we're going to factor a -4 out of this one, so it's going to change the sign, and it's going to make it a 4x. Alright, so what I'm going to do is now I will complete the square in the parentheses. I'm basically going to cover that up and complete the square. And this is going to turn into x plus sign half of 4 is 2. And then I'm going to check my FOIL. Let's see, this would become x squared. This would become 4x if I FOIL that out. And then I'd get 2 squared to make 4. So I would normally add 4 right there. And if you do that, you got the right mindset, and you just missed the entire problem, however. And the reason is because, don't forget, we have this -4 coefficient in front. So when I add 2 squared to make 4, I'm actually adding 2 squared to make 4 times the coefficient that I factored out of -4. So really, this is not correct. I'm actually subtracting 16, because 2 squared is 4 times -4 is -16. So I must subtract 16 on this right side to balance it. And I'm just going to clean up my equation, bring down what I already did work on. And over here, I'm going to add everything up. 19 plus 1 is 20. Subtract 16 is 4. And now remember, this is a hyperbola, and we want our hyperbolas to equal 1. So what we're going to do is we're going to divide everything by that number 4, and we're going to rewrite our equation. I'll write it here on the side. Our new equation will be y minus 1 squared over 4 minus -4 over 4 basically cancels, and I get 1. So you can just write x plus 2 squared. If you want to put it over 1, that's perfectly fine, though you don't have to. And this 4 over 4 also makes 1, so now I have my equation and I am finished. Alright, once again, check Google Classroom. Make sure that you are working on your CBA review, because it is a semester exam. And make sure that you are working on any assignments that you have. Let's see, next week on Tuesday you will have a quiz after lunch over hyperbolas and ellipses. And then at the day after that would be Thursday that we have class, so that will be our semester review day. You can work on the review, come to class with questions, and make sure you read on the Google Classroom assignment that you must post questions this time. We're going to make it like an online study guide. And then next week, 2 weeks from now on Tuesday, it looks like you will have your CBA test. It will count on the 4th 6 weeks, not on this one. Alright guys, have a good weekend. Hopefully this video helped. I know it's a little bit long, but take your time, go through it. After lunch, work on all of your assignments. See you next week.